Good evening, my YouTube viewers. It is Crystal here. I'm just here this evening because I want to do another code review. This code review, we're going to be doing the ANOVA hypothesis test. And before we actually do the code review, I want to actually talk a little bit about what ANOVA is. So when we go into the code, you'll know what ANOVA is. So I'm just looking at this website where it says, what is ANOVA? ANOVA is analysis of variance. ANOVA test is used to compare the means of more than two groups. T-test or Z-test can be used to compare two groups. Groups mean differences inferred by analyzing variances. ANOVA uses variance-based F-test to check the group mean equally. Sometimes ANOVA F-test is also called omnibus test, as it tests nonspecific null hypothesis, i.e. all group means are equal. Main types are one-way, one-factor, and two-way, two factors. ANOVA factor is an independent variable. It is also called univariate ANOVA as there is only one dependent variable in the model. MANOVA is used when there are multiple dependent variables in the dataset. If there is an additional continuous independent variable in the model, then ANCOVA is used. If you have repeated measurements for treatments or time on same subjects, you should use repeated measure ANOVA. Note, in ANOVA, group factors and independent variables are similar terms. So you've got your ANOVA hypothesis. So the null hypothesis is groups means are equal, no variation in means of groups. So H0 colon mean 1 equals mean 2 all the way up to mean P. And then you have the alternative hypothesis. At least one group mean is different from other groups. H1 colon, all means are not equal. The null hypothesis is tested during the omnibus F-test for all groups, which is further followed by post-hoc tests to see individual group differences. So these are the assumptions about the ANOVA. Residuals, experimental error, are approximately normally distributed. The Shapiro-Wilks test or histogram. Homozygosity or homogeneity of variances. Variances are equal between treatment groups. That's Levine's, Bartlett's, or Brown-Forsyth test. Observations are sampled independently from each other. No relation in observations between the groups and within the groups, i.e. each subject should have only one response. The independent variable should be continuous. If the dependent variable is ordinal or rank, e.g. linker item data, it is more likely to violate the assumptions of normality and homogeneity of variances. If these assumptions are violated, you should consider the non-parametric test of Mann, Whitney, U-test, Kruskal-Wallis test. And then ANOVA is a powerful method when assumptions of normality and homogeneity of variances are valid. ANOVA is less powerful, little effect on type 1 error if the assumption of normality is violated while variances are equal. It says how ANOVA works. Check sample sizes, equal number of observations in each group. Calculate mean square for each group. Level 1 is the degrees of freedom for a group. Calculate mean squared error. Calculate F value and calculate P value based on the F value and degrees of freedom. So one way ANOVA with Python, and we're just going to stop there because we're not going to read the entire website. This is just to give you a little bit of information about the ANOVA, and the thing that you can take away with you is the ANOVA, it measures more than two groups of information. And so I got the questions that I'm going to be working on from a YouTube video, and it's a statistics in Python course by Geeks Lesson. But I can't show you the video in this one because I'm on another video at the moment, number one, and two, my computer sort of like didn't work properly, so I had to reset it. So it's reset. So what we're going to do is, first thing we're going to do is we're going to talk about the code in R. And then after we've talked about the code in R, then we're going to talk about the code in Python. We're going to translate the code from R to Python. So first thing we're going to do is we're going to run this. So we run it. Okay. So we've got the question, does the rice variety influence average yield amongst these four varieties? And so the first thing we're going to do is we're going to read the data set in with dt equals read.csv, and then that's a link to the data set, and it says print dt. So you can see I've printed dt, so it goes A to D, and it gives you the yield. And it says a summary of the dt that gives you your minimum, your first quarter, your median, your mean, your third quarter, and your maximum. Tells you the length is 16, class is character, mode is character. And we do attach DT, and what attach DT means is that just goes back and checks the data set every time anything is done. So we make the variable rice mod equals AOV brackets yield tilde variety. So rice mod is the variable, AOV is the function for ANOVA, yield is the dependent variable, and variety is the independent variable. And then we do a summary. And so when we do a summary, we say that our F value is 7.212 and our P value is 0.00503. So a P value equals 0.00503, being less than alpha equals 0.05, meaning the null hypothesis cannot be accepted. So that means that the null hypothesis can't be accepted. That means that the rice variety influence average yield amongst these. It just means that it's not. And then what you can do is, well, that's not coming up here, but whenever we get to Python, we will show you a box plot, and you'll see a box plot in that. So now we're going to come over here to Python. We're going to look at ANOVA. We've got the same question, but we had to import pandas as PD, import seaborn as SNS, and import sci-fi stat. From sci-fi stats, import f_one_way. So dt equals pandas.read_csv, and then a link to the rice data set. So we're going to print it. And then we're going to print it, so you can see here we printed the rice data set. And then we're going to describe it, and you can see here we've got a description of count, mean, STD, min, 25%, 50%, 75%, and max. And then we're going to make a box plot of it. So we made a box plot. So you can see just looking at the box plot that the null hypothesis cannot be accepted, because you can see that D has a much greater yield than A, B, and C. So B and C are similar, but A and D are dissimilar. And then after we've done the box plot, then what we do is we separate the data frame by variety. So for I, G in dt dot group by variety, globals, it says dt underscore plus string I equals G. So it says print dta, print dtb, print dtc, print dtd. And you can see how we've got A, B, C, and D printed out because we made new data frames for that. And now we use our F underscore one way, and then we combine all four data frames together for the ANOVA. And then we have a F value of 7.212 and a P value of 0.00503, which is exactly what we had in R. But I felt a little bit happier with working with Python because I was able to make the box plot while I couldn't make the box plot in R. So I'm happier with Python. So now what we're going to do is we're going to go to the second question, and this was done by Fisher. It says collect a sample of pond water, divide that water amongst 4 different beakers, separate the beakers to ensure there is no cross-contamination. For each beaker, take 4 samples and count and record the number of amoeba. And the code that we used was exactly the same code that we used in the first question. The only thing that changed was we changed the name of the file. So it's instead of rice.csv, it's fisher38.csv. And we changed the name of the variable. We called it ikimod equals AOP brackets. Colonies is your dependent variable, and sample is your independent variable. And then we did a summary of ikimod. So you can see that we printed DT. So you can see the sample is in Roman numerals and the colony is in numerals. So, and then we do a summary of it. So you've got the length equals 28, class is character, mode is character, minimum first quarter, median, mean third quarter, max. Your F value is 0.525 and your P value is 0.669. So the in this instance, the p-value being 0.669 is greater than alpha equals 0.05. We cannot reject the null hypothesis. We did not detect a difference in the average of amoeba and the samples across the beakers. So you can see in the first example, we rejected the null hypothesis, and in the second example, we accepted the null hypothesis. So we come over here to Python, and as I said, the code is exactly the same. We just changed the data frame or data set. We changed the data set, and we changed the box plot. So the X variable is sample, and the Y variable is colonies. So we can come over here and look at the box plot that we created. So you can see that the box plot that we created, the boxes are similar. They're not identical, but they're similar. And so that gave you an F value of 0.52 and a P value of 0.669. So because you had your p-value of 0.669, which is greater than alpha of 0.05, we can accept the null hypothesis. We did not detect a difference in the average number of amoeba in the samples across the 4 beakers. And another thing that you need to know about this test is the F statistic is inversely proportional to the p-value. So if the p-value is high, the F statistic is going to be low. And if the p-value is low, the F statistic is going to be high. So in this example, we've got a p-value of 0.669 and an F statistic of 0.52539. But we look at the other example, our p-value was 0.005 and the F statistic is 7.212. So that just tells you that the p-value and the F statistic are inversely proportional to each other. So I'm going to go ahead and conclude this code review because I've covered everything that I want to cover about the ANOVA. And if you like my video, please like, subscribe, and share. And thank you so much for watching my code review. I look forward to making more code reviews for you in the future. But I also want to thank all of my subscribers for supporting my channel.